Great. All right. So what do you do? Masters, PhD, PhD which year?
Second year.
Second year. Year 5 year. Okay. Which professor? Okay. Okay.
All right. Good evening, guys. Thanks for having us here and participating in this career talk with Silicon Labs. So myself is Dixon. Okay, I'm the recruiter for Silicon Labs. And joining me today as a guest speaker is Mr. Shantanu. He's the design engineering director. Okay, so to kick off the agenda, I'll be presenting to you the presentation slides with respects to HR recruitment. Okay, so what I'll be presenting to you today is the Global University Program for APAC region. So I'll be the sole recruiter that is handling APAC region. Yeah, okay.
Silicon Labs is an industry leader in wireless connectivity solutions for the Internet of Things. We are pioneers in wireless technology, partner of choice in every major ecosystem, with a groundbreaking platform of silicon and software to advance the Internet of Things. The Internet of Things is transforming industries, growing economies, improving lives, and safeguarding our environment. And we're all in, 100% focused on the IoT. Today, it seems obvious the Internet of Things will be as ubiquitous and essential as electricity. Smart connected devices will be everywhere, more pervasive than any other electronic device in history, and with an even bigger impact on how we live, work, and do business. 10 years ago, it wasn't so clear. Yet Silicon Labs made a bet. A bet on our vision for a smarter, more connected world. A world in which devices are intelligent, connected, and everywhere. Running on batteries not for hours, but for decades. Easy to deploy, simple to maintain, and powerful in a myriad of applications. In homes and businesses, fields and factories, across cities around the world. That vision is now a reality. That world connected by the Internet of Things is here today, and Silicon Labs is at its heart. With a broad product portfolio, unrivaled breadth and depth, support for the broadest range of wireless protocols, talented engineers, and a culture of innovation and collaboration with our partners, Silicon Labs provides the products, tools, and partnership that IoT developers need to speed their innovations to market. We are experts in high-performance, low-power, secure wireless technologies. Wireless connectivity, which to some in the tech industry can seem like magic, part science, part art, is second nature to us at Silicon Labs. Our engineers make it look easy, but it's not. It's hard. Hard to crack the code on architectures that deliver high performance at low power. Hard to integrate the broad range of wireless protocols and make them all work together, from legacy and proprietary, through Bluetooth and Wi-Fi, and on to emerging standards like Matter, Thread, and Wi-SUN. It's hard to secure devices from the ground up. Hard to define a roadmap that supports the leading edge of an incredible range of markets. Silicon Labs is up for the challenge. We work closely with our partners, supporting their roadmaps, future-proofing their product plans. It's what we do. It's all we do. We're all in on the IoT, and the IoT is exploding. Millions of smart connected devices are being deployed throughout office buildings and warehouses, manufacturing floors and construction sites, in homes and businesses, and cities around the world. The IoT underpins infrastructure and energy grids, streamlines supply chains and manages manufacturing lines, predicts equipment failure in time for proactive maintenance, tracks assets and prevents losses, digitizes retail stores and office buildings, supports personal health and healthcare systems, secures homes and businesses, and sustains our environment. As intelligent connected devices are embraced in homes and deployed by the millions in industrial and commercial applications, the possibilities are endless. The opportunity is tremendous. Growth is accelerating, and Silicon Labs is positioned to lead, scale, and take full advantage of it. Together, let's build a more connected world.
Okay, so hopefully the video would actually give you a glimpse of what Silicon Labs is. Okay. Okay, so I'm the APAC UR and Experience Hires. My name is Dixon. Okay, so I have over 10 years of APAC regional recruitment experience in various MNC, mostly in semiconductors, okay, both in the front end and the back end, okay, yeah. So you can reach out to me, connect with me on LinkedIn. We can chat over LinkedIn or maybe email exchanges, okay, if you have any questions for me or regarding any opportunities moving forward, okay.
Why is it not working? It's working. It's working. Yes.
Okay, so the agenda for my philosophy, okay, the Silicon Labs intern and CG's experience, and our interview process and how to get yourself being prepared for the interviews. Okay, our program philosophy. Intern and NCG hires are an integral part of our overall talent pipeline and strategy. We want to create a strong, diverse talent pipeline, and we want to convert talent that meet our expectations. Okay, so the objective of all these global intern program is to build a diverse and scalable talent bench to fuel the growth of our organization. So when we hire an intern who actually did the internship with our organization, we actually try to groom the intern. Okay, we teach them within the best of our ability. And if let's say the intern is performing well and we think that this intern is a great talent, we actually convert them to a full-time position. Okay, so that's the sole purpose of this internship and NCG programs. Okay, so as I just mentioned, we provide internship to students as a funnel and pipeline for our future NCG positions. So when I visit universities, a lot of students will come to me like, Dixon, so typically when you guys start hiring and when can I start to apply for the role? That's why I have this slide. My boss actually asked me why do we need this slide, but I told him say that a lot of students actually post me this kind of question. So for NCGs, usually the conversion will start after you graduate, okay? And for maybe those who didn't did the internship grants is typically like mid-year or maybe end of the year for some cases, okay? Okay, the internship for graduates like yourself or PhD students, you guys actually do a part-time internship, so it doesn't really apply to you lah. Okay, so the recruitment window usually occurs during August to October or January to March period. Okay. So intern, I don't have to explain to you. So intern conversion, like I previously mentioned, we try as much as possible for those potential interns, we will convert them to full-time positions. The reason being because they have already interned with us, they know the work requirements, the work ethics within the organization. Okay. So what our interns and NCG says about Silicon Labs? Okay, they say that we provide impactful, innovative projects to them. We provide ongoing technical development, access to subject matter experts, okay, products that they can feel good about, okay, and they are actually bringing their whole selves to work every day. They find it a very meaningful work to do day in, day out, okay, and they have visibility throughout the organization. So a lot of maybe new college grads like yourself, you may think that I'm just a junior guy. No one will actually know this about my present, but that doesn't happens in Silicon Labs. Okay, being an intern or being an NCG, you're actually very valued in the organization itself. Okay. So we actually have also this intern tech symposium as well. So this interns symposium is actually an opportunity to share the intern project experiences with all the employees at Silicon Labs. Okay, we want to make sure that the interns leaving before the symposium also have a chance to showcase their projects. Okay, modeled after our annual technical symposium, this event gives interns a chance to showcase their work. Okay, the project showcase what occurred in the internship last few weeks. Okay, so we invite the interns, we'll give them a booth, then they will actually explain to all the employees within Silicon Labs about what they did during their internship. Okay. So each intern has 7 minutes or so, okay, to present their project experiences and to open to the floor for any Q&A, okay, post presentation. Okay, culture is key, okay. Silicon Labs is a safe and trusting environment for everyone. Okay, we all benefit from an environment free from harassment, discrimination. Okay, we encourage everyone to have open communications with any concerns early to prevent an uncomfortable working environment. Okay, to clarify any misunderstanding. Okay, correct concerning behavior early, and also to ensure that the situations are handled before they become severe. So as you can see, we are a very, very transparent and open company, okay? So you can see everyone is enjoying. This is actually the cafeteria area whereby we have pool table, table tennis table, and also a darts area, okay? So interview process and being prepared. So you might have questions. So Dixon, how do I get myself prepared and get myself through the interview? Okay, so the internship and full-time engineering areas that we're looking out for or we are hiring for: analog digital RF, design and verification, okay, software and software QA, embedded or also full stack, okay, and also validation and systems, okay, CAD and product test engineering, and also last but not least, applications and product management. Okay, so the interview process, we will meet the interviewee, okay, go through an online assessment, then followed by a technical round 1, or if there's a need be, a round 2, then following a HR discussion with the hiring managers and the panel itself. Okay, then we'll roll out the offer and we'll start onboarding if you accept the offer. So you might ask me, so Dixon, what am I being assessed on? Okay, the technical assessment of it, technical aptitude, your base level technical skills and growth throughout the summer. Okay, problem solving skill. Okay, your project completion, meeting deadlines. Okay, and final completion, potential, demonstrated ability to implement feedback and eagerness to learn. So what about the soft skills? So is how you actually can adapt to Silicon Labs culture. Okay, curiosity, ask questions and is eager to learn. Okay, inclusivity, encourages others to bring their whole selves to work. Okay, integrity, that is the most important thing that Silicon Labs believe. Okay, do the right thing. Okay, adaptability, resourceful and implements feedback. So this is all the criteria that will actually assess the candidate. Okay, so I'm not too sure whether you have visited the Glassdoor's review. As you can see, we have a very, very high rating. It's like more than 4.5. I don't think you can see such high ratings for a lot of companies. Okay, so you can see the reviews on the Glassdoor, and we are also a certified company, great place to work. Okay, so do follow us on LinkedIn, Twitter, or even Glassdoor for the latest updates. Okay. So what you may think, what's the experience working in Silicon Labs? Okay, so the very first picture that over here, we actually crossed the 1 billion revenue mark, and we celebrated this event, this milestone itself. We work hard, we play hard. Okay, and this picture over here is our CEO and the executive team that visit the Singapore site. I think most of the time when you work in a company, you don't even get to see the CEO. Okay, but that's not the case because the CEO and the executive team believe in being together with the ground itself. Yeah, so it's a very, very closely knitted company itself. And this is the celebration that we had in Chinese New Year, and also the tracking event. Okay, so I open up to the floor. Any questions for me with regards to HR? Yes.
I'm a master student from the NTU TUM ICT program.
Okay.
So we have mandatory internship.
Yes.
And also, but however, the last course will be at the end of June. And you said the recruitment date is around June. Is there like a hard deadline?
No, it's not a hard deadline. Those timeline is more for undergraduate students. So it will be on basis case-to-case scenarios, like for example, postgraduate students like yourself. Yeah. So if you need to have a internship program, do feel free to reach out to us. Yeah.
Meaning over the past we had a lot of TUM interns and thesis, so it's usually 3 + 6 months, so 9 months program, right? So from June to March. So we have that experience with NTU TUM students.
Great. So if you say you can extend the 6 months to 9 months?
No, so as part of the TUM program itself, it's comprised of 2 sections, right? So one is the internship and then the thesis work.
Yes.
The thesis work you can do with your professor or you can do with the company. So depending on, we can come up with the thesis title and then we can extend the internship to make it a 9-month internship.
Okay.
So usually that's what makes more sense to us because 3 months is usually very short.
Yeah. Okay. Thank you.
Okay. So
This internship, will you give any financial assistance to the students?
sorry, I got
During the internship, do you support students financially? Like any financial scholarship, like anything?
Yeah, so all the internship comes with internship stipend and based on whether it's undergrad, graduate, or so it depends on each level. We have a different levels of financial, of course, compensation because it's eventually you're doing the work for the company. So that's part of it, of course.
Yeah, so typically for part-time students, because you guys can only perform like part-time, because if you are not a local Singaporean, if you are overseas students, you only can do part-time basis. So it's like on an hourly payment mode, yes.
It's depend on number of hours basically.
Yeah.
A whole number of hours. That's the agreement that we have with the company and students.
We're expecting for full-time internship. Is that possible? Although we're overseas students.
Full-time internship, I don't think so for postgraduates.
No,
Yeah.
this is the TUM they have for full time.
Okay.
So for TUM is different.
Different.
So when you are doing a PhD or something, this is coursework. I think the curriculum doesn't allow you to do internship, then we do part-time. But if the curricula have already a full-time time allocated for internship, then full-time is of course not a problem.
Right. It's good to hear that. Thank you. And as the slide says, when the intake time is June, the recruitment time is between January to March.
No, like as I said just now, my timeline just now is more for undergraduate students, so it is really case on case scenarios.
It should be at least 3 to 6 months before you start, right? So at least you should have that kind of. So whenever is the time, you should at least look for 6 months before look for the place.
So the time for it open, we only need to like follow the linking and check for
Yes,
the
yes,
updates.
yes, yeah.
Okay.
So it's best that you follow the various social channels so that you can have the latest updates. Yeah.
Okay. Thank you very much.
Thank you. Okay.
I want to ask about the newcomer graduate. So, if I'm not correctly, the period is around 1 year.
Newcomer graduate.
New college grad. New NCG.
New college graduate.
Yeah.
Yeah. How long is the duration and how is it differ from for a normal probation period?
All the probation period for all, including new college grad, is 3 months.
Okay.
Yeah.
So probation and the new college graduate, they are totally different.
No, new college graduate, that means no experienced people, that is fresh leavers, fresh graduates like yourself. So that's what we call new college graduates.
Yeah. So means that for new college graduate, they should have like near zero industrial experience.
Yes,
Okay,
yes.
yeah,
Typically,
yeah,
yeah.
The classification is less than 2 years of experience.
Yes.
So if let's say in my PhD work,
Yeah.
I have touched a little bit on industrial self things.
Mm.
So should I be joining the NCG in that case?
It
Or
really
is it up to the HR?
So NCG and a job grade is two different things. NCG is a classification that you are coming up for college, right? But if you are doing an undergrad versus a master's versus a PhD, you have to do differently. Okay, so the levels and then the expectations levels and the skill levels will all vary with respect to the education that you have. Right, so there is no like, oh, you have to cross this 1 year NCG to be a full time or something. It's nothing, right? It's all the same. So any employee that comes in are treated exactly the same versus the NCG or a 20 year experience with person. Right, and then the candidates are judged based on what they are bringing to the table and the education level that they have.
Understand.
Okay, so without further ado, then I'll pass the mic to Shantanu, Mr. Shantanu. Okay.
Thank you. It's perfect. Thank you. Thank you, Lisa. So now you know how to get into Silicon Labs. So this is more of a not specific to Silicon Labs, but generally talking about what is the general trends in the industry, what we think has happened and what will be in the future. So topic of my presentation is the future of the connected world, and connected world is a big deal for us because that's what we do. We connect things. We are embedded systems design, and so we bring in the connection to all parts of the world, not just from a data center, from mobile, from cellular, but all the way to the edge. So that's the IoT, so Internet of Things, connecting machine-to-machine connectivity. So my name is Shantanu. You can call me Shan. I'm design director in Silicon Labs, and I'm also graduate of NTU. So I have graduated many years back. So this is very familiar place for me, and very happy to come back here to talk to people. And really happy. Every time you call me, I'll come back. So not a problem at all. So I'm happy to talk to people as much as possible, because that's what I also do, trying to see how to groom the next generation of the designers to come into do things for the next 20, 30 years. Yeah. Just to go back a bit, the decade, what happened in 2011, there was some random person said from Ericsson said more than 50 billion connected devices were going to. There were some random guesses. At that time, we were at maybe 5 billion, 6 billion. It's like, how is it possible that 10 years you can just get to 50 billion, 10x, or even 7 or 8x, or what was a connected base? How can it go to 50 billion? So people thought it was just a crazy thing. Then second big event happened. iPhone came up, iPhone 4 came up. Then they came up with a specific.
Room is not shared, that's why.
Is not shared.
Yeah.
No worries. Sorry about that, people, whoever on the call. Can you hear me? Whoever is on the call. So much. Is okay? All right. Let's see if this one works. Okay. So finally, hopefully no other things. Okay. Let's see if we can get through this without any more hiccups. Sorry. Okay, so where are we now? Let's kill this one. I don't like this banner. Okay. So where are we today? Today is still, I would say, a bit dated, because information always comes as a after effect. So it's 2021, 2021 data. So where are we now in terms of the API research said we are at 34.5 to 40 billion connected devices in 2023. Not so far off, huh? This one was mentioned at 50 billion in 2011. We are at close to 50 billion, maybe and what's IDC say? It's like 55 billion in 2025. So it's 3 years from now. So if you say that this is the kind of forecast 10 years back, I will take it. It's within the error margin of that kind of decade-long forecast. And maybe we can still connect the cat to the cloud. All right. Okay, so we talk about, and how does that, all that 50 billion devices or 30, 40 billion devices that is connected, which is the bulk of it, right? Where is all the things connected to? What are the different classifications of this? This is the cloud, this is the data centers, this is the PCs, this is the mobiles, and then all the devices. So these are the few, I would say, the classifications of the different segments of the whole connected domain in the world itself. If you look at the data centers. You can see maybe hardly 10 customers really buying data centers, big servers and stuff. Storage maybe in thousands of million of gigabytes. It consumes a lot of power, so it has to be AC powered. Device lifetime will be close to 8 years. Costs quite a lot, 10,000, tens of thousands. And when is the time, when it started from? 1980s. The data center timeline has started from 1980s. Do you know what is the closed volume? Any guesses?
10 billion.
Two?
10 billion.
Closest one wins. Any other guesses? Say 10 billion, is it? Okay. Any other guesses? It's an order of magnitude different. Few order of magnitudes. Any other guesses?
100 billion.
100 billion. I'm already saying the total connected base is 34 billion devices.
Okay.
Okay, so it cannot be more than that. Because if say data center is not connected, you cannot say that, right?
Really, really.
10 billion. So the base of it, where there is a cloud, all the cloud, is similar to 13 million. That's where it all goes to. PCs we all familiar with, right? So there are like 5 customers, major customers and stuff, like who really, if you talk about, when you talk about customers who are creating, not for consumers, but who is creating, how do you, like, okay, I see there, few people do the PCs market. And this started from 1995 mainly and driven to 2005 itself. These are PCs. What's the volume of it into every month? One billion. Not even close. 5 billion. Sorry to say, 340 million. So low. Okay, so how does it add up? Actually, it doesn't add up. But you can see that it has grown in the order of magnitude. 13 million data centers, okay, 340 million. It's about shipments I'm talking about, not the installed base. Okay, not the existing, okay, you don't count the number of PCs in everybody's homes but how much is new ones that have been sold. Okay, so the global shipments in 2021. Now talk about mobile.
3 billion.
3 billion. Let's see who is the closest.
20 billion. 20 billion.
20 million. Who said 1 billion? Okay. We have been ahead, at least in the close order of magnitude. All right, so we are getting there. So 1 billion. What embedded? How many things you have embedded systems? 30? 30 is the install base. 3 billion? 3 billion, 40 billion, you said something. 42 billion? 15 billion. Who is the closest? Nobody. So that is the kind of, see, the scale that I'm talking about. What makes it connected world? It's not the data centers and the cloud and talk about what is there, the cellular and everything, mobile. Mobile also is connected only 1.4. But if you look at the volume that we're talking about in embedded systems, is 10x more than anything else. Right? So anything that is coming up in the future from now on This embedded systems will outrun all other types of the networking systems because there is a scale. So it's a tree, right? Pyramid. So you go from data center to spread out to PCs. PCs get stuck there. PC doesn't work. From to mobile and then embedded systems. Okay, so but there are a few things, right? Customers. It is not dependent on any one or two or three or handful. It is going to thousands of customers. Storage is hardly anything, but the battery life is 10 years with 1.7. So the amount of the focus of area that we want to work on is not so much as like, okay, let me make the most performance out of these devices, but how to make it last as much as the battery itself. After the battery, you can go with it, get a new one. And the cost, you can see the cost has really shrunk from an order of magnitude, from 10,000 to 1,000 to 100 to $10. And that's why this is a booming portion of the overall industry in the connected space. And it's still going. It's 2015, it's really boomed, started to boom at 2015, and you can still see it's going very strong and it has a long runway ahead of it. So now we come to say, okay, this is important for embedded. Like, what do we do in embedded? Where are the key things, or the key milestones and the key steps that have happened over the timeline of the embedded system? So I have broken down into 4 different segments. What it has been, there are few things that have evolved over the last few years. First has been the compute for 5 years or so. Connect again for 5 years. Then you have the secure. The security has come in really big now. And the last one that is we are living it now is a smart, bringing the smartness in the overall embedded space. I will go through each one of them just to showcase what's all this about. So, compute. So there are a few how to read these slides. So if you can look at the left side of it, it is basically giving you a report card of what is going on for each of these timelines. So this one will be what was before. When you talk about this 2007 to 11, what was it before 2007? What changed? And what was the impact of that change? And what was the spec that finally came up that this defined this overall the change that happened? So do you know what were the different embedded processors that was there before? Anyone studied embedded processors that have been there before 2005, 2004?
8051. 8051.
8051. 8051 is not really, it is embedded a bit. Yeah, I can get that. Yeah, but not so. Meaning it was 8-bit was there a bit, quite a bit. 8051. We have done a lot of 8-bit MCUs. So 8-bit, 8051 is one of them. Anything else?
MSP.
MIPS. Let's see if it works. Sorry, short too much. So MSP is there. Atmel, PIC, PowerPC, Renesas. Those are the pieces that the processors that were there before. And then I already showed you, so I'll not ask you again. After that, what happened was development of mainly 2 major players, and that really brought everything together in a consolidated architecture itself. So STM32 was a big deal. So STMicro, the STM32 chips, not chips, the processors itself, and the ARM. ARM really drove the industry totally upside down, because after that, the ecosystem grew so much within the ARM itself that nobody wanted to do their own custom development for processors. They said ARM is the gold standard, and all the developers, all the software developers, they just focus on doing just ARM-based embedded software development. So that was it's not so much of the hardware capabilities, but also the overall ecosystem that goes around it. So that was the change that happened. So the proprietary architecture really lost a lot of share. And you can see how the Cortex-M, that is one of the ARM processors, and M is a mobile. So it's like a very compact and low power architectures that you have. And if you see shipments really exponential growth. And coincidentally, ARM just had IPO. It is now what, $60-70 billion company. I don't know how much market cap. So it was private for so long. Now it become finally a public company. And if you look at, if you just ask any of developing the open market, right? Who will you consider? Which chip family will you consider for the next embedded processor? You can say 80% will say ARM. And that's why as chip design companies, we can never discount ARM. So I said, even though we don't like ARM, it's not that we don't like ARM, but even if we say that we don't like ARM, we have to do it because that's what the customer wants. That's what the customer wants. So how does that evolve? This is the STM32F101, very popular chip in 2007. It had Cortex M3, and in fact, STM has also both flavors. The STM32 really used a lot of the ARM, and the flash memories, the sleep powers. The technology node was 180 nanometer, and the specs was modest. I would say not many connectivities and not much of features. Then next, I would say 2012. It was a very efficient Silicon Labs MCU. It was part of our own internal development. So Cortex M3 80 megahertz. We took it in a sleepfrog, the sleep power, sleep current to 0.6, less than a microamps. And so the power active was also significantly dropped using the same technology node. So we didn't draw the technology node, but we really acted on the power architecture significantly to reduce it. Then it stayed for a while. Then Ambig came in and says, okay, we can do much more better. So we jumped to M4, increase the frequency, increase the memory, but power, they dropped to 10 microamps, and says the key thing was this one. The active power dropped to 3 microamp per megahertz. That was the key. So because now you are able to do more with the less power when you are running it, not just sleep. Sleep, you said, okay, sleep is fine, but I want to do more things when I'm running it. And it has a lot more features inside there. So that's how the migration of all the microprocessors has been. So Connect is a really important part of the overall thing. And Connect, there are few things that has really happened. Initially, there were a lot of fragmented protocols and proprietary. There was very little that you can work together with. It's always paired with something. You always pair with something and work. So you cannot use it for anything else. Then what happened was this, I was mentioning about this Apple smartphone came in and everybody says Bluetooth. So Bluetooth was a standards-based protocol that really helped to accelerate this connectivity, and anything is Bluetooth symbol, you can connect anything. So that's what started, interop started getting better. So the wireless alliances grew, like we have the Bluetooth SIG and all the other protocols that you have, and the interop really improved significantly. So if you see how the embedded and cellular, so there are two charts I want to show you. One is based on just versus embedded versus cellular. And you can see the difference in the growth rate. So the install base was pretty big for embedded. So cellular was suppose this is the cellular itself grew significantly because smartphone really that craze started. And then after a while, it got stagnated in terms of the growth. The initial growth was there for 5 years, then it slowed down. But if you look at the embedded, that growth story is still going strong and will keep on growing more. And that is just Bluetooth enabled. Okay, so Bluetooth enabled cellular versus embedded. Now, as I said, wireless doesn't mean there are two ways, standard based as well as proprietary. So proprietary means you just do any kind of stack, you do your own personal stack and you can just run it. And you can see that for the proprietary, it hasn't changed at all for the last 7-8 years. It has been stable, it's good, but it has been stable. But if you look at the standard based, the adoption rate is much bigger. It has become 2x versus this one has grown like maybe 10, 20, 30% at most. So the standards have really grown much faster than the proprietary. And that's what shows that having that this catalyst of bringing into Bluetooth and creating more standards-based solutions has been the catalyst for bringing up this IoT space. So in terms of the examples, this has been the first one, Nordic. This is our one of the main competitors actually. So it had the Cortex M0 Bluetooth, and you can see the sleep currents and all. We fight a lot on the sleep currents. We want to make it to a single microamp, 1 microamp for sleeps, but with ability to come up fast and then execute. It is still in 180 nanometer and a lot of other features. TI, this is a very good chip, CC2640, which has M4, 48 megahertz, Bluetooth 4.2, and you can see the Bluetooth standards are still there, but it has gone to 4.2, 5.2, 6.0, and so on and so forth. The power sleep is reduced significantly. Again, the ability for our sleep currents to be at this lower level becomes more and more challenging as these devices goes down because it's leaky. It's just devices don't allow us to. So we need to play a lot of tricks to make it happen. And the technology node has shrunk to 90 and with much more features. The Silicon Labs B22 is our flagship chip right now, which is selling a lot, and it is Cortex M33. So it improved from M4 to M33. It added security also, of course, and the Bluetooth 5.2. So this is in 40 nanometer flash, and so it has a lot of other features. The security features, I'll talk about it in subsequent slides. But overall, you can see the connectivity, the journey of the connectivity has been pretty consistently going in the right direction, and the complexity of it. So security. Security is a concern when you have so many things connected to your network. It's prone to hacking and prone to data loss, prone to your identity theft and stuff like that. So there are a lot of issues with connected devices, and there is a lot of push factor from a lot of people that why should I put everything out there because it can be easily accessible and you can lose critical information of yourselves. So, for example, there was this the locks, door locks, which is smart door lock. There's a very, very bad security flaw that enabled it to be hacked in 1 minute. So that's scary. For example, you have all these smart connected vehicles. It's scary if someone else can take hold of it. I mean, all this happens in the movies, but actually can happen in reality as well. And the heart implant, these are all smart devices. So it can be triggered, it can be changed the behavior from somewhere very far away. So these are real life scenarios and real issues that we are dealing with when a security happens. With respect to security for these devices, anything that is connected can be hacked. So how we have managed it. So in terms of if you look at before it was brute force method. So what happened was we created standards. So ARM steered a PSA certified. So we have certification levels. We say this devices have this certification level for security, and you can then use that certificate that okay, you can have that level of security if you use this device. And so MCUs provided dedicated security processors. So that means there is a main processor and there is a security processor. That is the first one to come on board. Do anybody add any information on how security works in any embedded devices? Have you been looking at it?
I worked on some TPM USAs. So
TPM?
Basically you have another TPM core that has a like embedded memory, has a kind of security key, and then you verify the boot up whether is it valid, is it okay? If it's checked, then you start to boot from the
okay. Very close. Good. At least you have the concept. So what happens is there's a main processor, but main processor it's used for performance, but you need to have a separately controlled, isolated system, which is a security system. It's also called secure enclave. It's a term for that. So it's like you have an isolated system where you have your own processor. It will have something called a puff. You know what's puff? Physically unclonable feature function. So you have something that comes up with exactly based on a physical characteristic of this particular chip, because each chip has a different doping, slightly different ways of fabricating it. So every one comes up with some slightly different characteristic versus the next one or anybody else. So using the physical differences between these devices, you can come up to a unique number. You come up with a unique key for each device. And that key you can verify against yourself, make sure that you are not you're not getting hacked, you're not under any hacker influence. You will have glitch. Any people do glitches to get off the reset and read out the keys. There's a DPA, a differential power analysis, because when you do encryption, for example, you do AES encryption. If you do your power analysis, you can easily kind of figure out what key you are operating on. So there are a lot of things that needs to happen to make sure that your level of security for your embedded devices is strong. But of course, your system is as secure as the least secure thing in your network, right? Of course, so every part of the network needs to be secured in a way that you have the same level of security. So the point is that we have been doing this security aspect of it before security was really a concern. Nobody wanted it. So in 2021, we came up with this chip and made it into production. Customer says, disable this feature, I don't need it. I'm just turning on my bulb. I don't need a security. But now they say, oh, you had a foresight. You had thought that security was important because it's the biggest link that matters. So everything in the network needs to be secure in a way that you don't get hacked. The whole network doesn't get hacked, or whatever part of the network doesn't get hacked. So next big thing that is coming up is being smart. So smartness is, so how, if you look at the overall pyramid of connectivity, how does it happen, right? So you have those edge devices, which is sensing and doing some kind of control and capturing a lot of data from your edge devices. And what is happening is now connected all the way to the cloud, goes to data centers, do a lot of the data crunching, and create some intelligent decisions at the end of the day. Now, is it really necessary? Is it really necessary that you send zettabytes of data over the network to someone somewhere far and then bring it down back? Why don't we just add smartness to the edge itself? I think that's where the industry is going towards, to add the smartness at the edge devices so that you don't have to have that data going all over the place. If you want to have a catalyst, we don't know yet. It's not there yet. So either it will evolve slowly as normally, or there may be a catalyst coming in to really push through to create a new wave of the smart devices. So what are the use cases, for example? So if you have critical equipment and you want to have predictive maintenance or understanding when they fail immediately and at a very small instant, and you want to have the turnaround time very quick, very fast, you need to understand immediately. And so if you cannot wait for it to go to the cloud and come back, and you're also dependent on the network bandwidth and network availability as well. So the emergency systems reliability you want to increase at the lowest level. So it can either detect between a pet or a human or whatever, right? So those kind of false alarm detection need to be reduced. And sometimes you want to call saving lives. So there's a feature in the Apple Watch that if you fall, you can call 911 directly. So some of the things that you need to have it at the edge so that you are able to make the decisions immediately, fast, without independence. So there are some things available out there to look into it. Some people are doing, for example, Sentient is doing keyword speech. So keyword speech like Alexa, and then you can do something, right? So it's keyword detection, wake word detection, speaker identification, so you know who is speaking, So audio event classification, environment event classification. So classification of those events is important. So there's a lot of machine learning and artificial intelligence that is being put into these devices. We have this recently developed chip, which is done, actually it's done out of Singapore. It has this audio pattern matching, sensor signal processing, voice commands detection, and some low resolution vision, because the throughput of this is really not that great. So you have to understand, we have to balance a few things. We don't have the overall power of a data center or a PC to do all this computation. It's still operating on a battery. And we don't want to consume so much on an always on way. So we need to always do a wake up, do have a low resolution detection, and go back to sleep so that the battery life is not impacted. So what happens in 2025? We don't know, but we can guess, right? So for example, it can be a M85. So next, the Cortex latest, we are in M55, 75, then maybe 85. Or RISC-V. Anyone knows RISC-V processors? Yeah. So RISC-V is also something is up and coming. People are still think ARM is king, but RISC-V is really something coming up strong. In fact, in our chip, we have one ARM processor. Everything else is RISC. Why do we have one ARM? Because it's needed by the user. User needs to develop the code. Otherwise, everything that is done internally, we all change to RISC-V because it's free, open source. Right, so we use RISC-V, all the different cores, and it will have a Bluetooth and a Wi-Fi. Why do you need Wi-Fi? Because you need the throughput. You know the data that is coming in a vision or any kind of the high data throughput that you need to have from the sensors. So the memory and the flash and RAM will be really going high. It will most likely be a 20 nanometer logic. You will still have a 2 to 5 micron because it's still battery operated, and you'll have always on audio and video, speech recognition, facial recognition, object detection, and on device training. That is a killer, because a lot of times when you do the artificial intelligence, just inference, inference is easy because you put in the weights in your models and you will get your result. But if you want to keep on fine-tuning your models based on what your data collecting on a day-to-day basis, you need to be able to train it. And those training cost a lot of power and cost a lot of memory and everything. So this will be game-changing. As soon as someone can do on-device training, things will be different. Okay? So that's something everybody's working on. Let's see what comes up, right? Okay, let me check. Need to go faster. Want to just share how our story, Silicon Lab story, has been through the different generations through the different timeline that we had, from point to SoC to multi-band, multi-protocol SoC, and now we have this secure, smart, and cloud connected in Series 2. So we are currently working on Series 3. So, but this has been journey so far till 2022 and beyond. But there is also more coming in 2023, 2024, coming in Series 3 that is currently working on, and then that will open up a new domain for us to look into that. I will try to skip these things a bit because I think I'm just. So if you look at if you split up how things are from an install base point of view, so we have 34 to 40 billion install base and 11.5 devices that we have, and each of them are huge markets, right? So you have 1.5 billion just on home automation, 700 for industry inventory, lighting, and so on and so forth. So they are significant. Each of them have big buckets where we actually targeting and focusing our attention on. So what has that got to do with us, right? People in this room, what do you need to do? So suppose someone wants a glucose patch. You know what a glucose patch? Put in here, you want it for 2 weeks, 4 weeks, and then throw away, right? What is something important? Oh, I want this for 6 months. I don't want to change it. I don't think so. The physical patch will stay, maybe the electronics will still stay, but the maybe physical patch goes off after 2 months, 2 weeks anyways. But suppose someone wants to spec, okay, I want to develop something. So then you go back to say, okay, let's understand what you want, how we can do it. They said, okay, I want this power domain. This is my battery that I'm using. And so let's understand specification, understand when we can provide it to you, and so on and so forth. So it creates that kind of specification creation from this device. And then you will do your chip design. Chip design will come with your digital design, your analog design, your RF. You create a lot of IPs with this. Then it's not enough to design chips, right? Meaning you are research students and a lot of people, you have to understand that you have to productize a chip. Productize a chip, then that means you have to have a test strategy. You cannot just do a chip which says, oh, I can't test it, and I test it quickly. I cannot spend 10 minutes on testing a chip because then that will be the bulk of the cost of the chip. So you need to have a way to do a built-in self-test for the chips and understand a faster way to do it. And a lot of times, software development happens hand in hand with the hardware development. You cannot just work in isolation. So you need to build up software development also. And once you have the chip design, then you are in the mass fabrication. You are taking out the chip, going back to you have done your design, you have your chip layout, goes to wafer, bonding and packaging, and everything is coming out. And a lot of the times when we are doing a wireless chip, it's not enough to do the chip, but it's also needed to do a module, because we need to have certification, FCC certification, or whatever certification is needed. Because once it is a pre-certified module, it's easier for the customer to design into their products, because they are not wireless people, they are product people. So we want to help them as much as possible with their design activity or the product development activities. So once you have that, then of course you will do all of the testing, and then of course it will have you'll go with the production support. So that's keep on cyclic thing that keep on happening. So this is very fresh out of the oven. So I just want to give even though this is not the right audience, but I just want to, if you want to spread in a word of mouth, that it is the importance of chip design is recognized by the government. People are doing a lot of effort to drive this training. So Gan Kim Yong, is a minister of MTI right now. He announced this in the dinner that he was a guest of honor yesterday. That there's a new 6 months training program for the IC design will be launched in summer of next year, August 2024. Currently, this program is focused on digital IC design. This is curated and reviewed and provided by the industry to NTU actually. Prerequisite is that you have to be at least a bachelor's of engineering or computer science. You have 400 hours of 400 hours of teaching, out of which 40% will be lab or hands-on. And trainers will be from NTU and NUS professors and also industry experts. The structure will be 3 months of basic course and 3 months of an advanced course, full-time and part-time. So already you can have engagements with the companies to start working while you're doing the advanced course. Funding, we have already had approval from SSG, Skills Future. So SSG grant is available for the basic now. Advanced will be worked on by end of this year. And for EDB and the companies are working together to finalizing the remaining support structure. So at the end of the day, what we want to do is the students get to study for free and still get some salary. So it is a win-win situation in a way, because as a company, when you come into as you talk about NCG, new college grad, there's a lot of training still need to be done, right? So there is still a gap that we have from academia. When you go to a industry setting, there needs a lot of training. It can go up to 1 year. And that training, you are not as productive as well during the time. And also, you will take up time for some of your mentors or trainers that you will have in the company also. So this one will help to free up that. So the companies will say, okay, I'll send you to this course, and maybe you are 50-60% there. So the next hurdle will be not as high, and maybe more companies focused training will happen when you come on board. And for the students, it's a training. So as soon as you come out, there's still a training that happens, and to expand your skill base. And this is a wide enough course that will cover all aspects of digital design, rather than only the thing that will work on. So it's still a win-win from both the students as well as the company. The first one is August 2024. Cohort size is 30. So if you want to contact, if you want to share information about it, please share it. The PACE, professional and continued education function in NTU is the one to be contacted for at least getting information more about it. So official launch hasn't happened yet. So I'm giving a precursor of that. So it will come up very soon. Announcement will come up very soon, and you will soon see some, at least some emails or communication from the PACE itself. I'm saying it's just 15 hours back. So it's still very, very new. It just came out in Straits Times, this news that it's on the left hand side of Straits. So again, I think I have said enough. I think you have seen the video from Silicon Labs. So it is just consolidating everything that you have. And lastly, I want to just say key takeaways for all the engineers. What are the things that I think it's important for you to look into? Energy, system level understanding. So if you want to go to if you want to make a mark in IoT, energy is important. Energy is not just, oh, my power mode is this, but for the entire operation of this device. So the system level understanding is important. So how you can save power overall in this device or the entire use case. Wireless convergence, understanding of protocols, use cases, and how things is merging together into how the standardization standards work and how is it evolving. Security mindset is important. As I said, and if nothing is more important in this connected world, if it is not secure, it is going to waste. Edge computing. So the smartness will come in, neural networks, TensorFlow, DSP, audio video integration. Those are key in the IoT space as we go into smart domain. And the application. A lot of times we can make the device, but we don't know what it can be used for. So having those entrepreneurial mindset and thinking about what the applications that you can use it for, that will be also a challenging or interesting space that you can go to as this technology gets more pervasive and more ubiquitous across the world. So with that, I think that should be all. So I think here we go for the next 10 years of our IoT life and see how things go. So happy to hear some questions. Anything for me? I heard so many. You have to at least match the question that you had for Dixon. All right, let me ask you some questions. So what did IDC say about the number of devices that you will have in 2025? All right. Okay, so that goes one bag.
Okay, so please help us to clear the bag so that we don't have to bring this back to the country.
Yeah.
Yeah. So yeah.
So we have two winners, right?
Yeah, there were 2 winners.
Yeah.
What other winners? Yeah. So then let's see. What are the four timelines that you're talking about? What are the 4 themes of it? Processing of us. No. 4. There were 4 different themes. No. Just one person says all 4. How the connected ecosystem grew,
compute and connect in the kiosk one.
Yes. Perfect.
I was missing the second.
So you're missing the second one. Okay. So when was so that's one. So which one was the connect timeline? Not quite.
2007 to 20.
After 20? You were close. Yep. So what is the full form of puff? Oh, I forgot. There are a lot of participants on the call also. I don't even have them. Anyone? What is the full form of PUF? Sorry? Make sure you can get it right, otherwise people will take that. That is right. That is the right word.
I know that. I know.
You know P?
Physical. Then
He has the U.
feature.
No.
No.
No. No. It's the function. Physically untunable function. I mentioned a word where this security feature stays in what? Right. Secure enclave. Yes. So which one iPhone, the first iPhone came up with which version of Bluetooth? Who was first? Okay. And which ones do you see on the screen? The last one, the last. I showed some three devices which have Bluetooth. There was the 4.0, there was the 2.3, and then the next one, 5.2. I won't give you again, so you don't bother asking answers. All right, how many do we have to go? So, Dixon shared one of the photos that we're celebrating. No, not the kind of something from corporate side, number of sales. Yeah, what was it? How much was it? 1 billion? 1 billion. You already got it. Come on. Anybody else? Okay, then we go for one more. How long is the probation in Silicon Labs? How long is the probation in Silicon Labs? Yes. Okay, two more. Oh, still got three more. Who is left? Who didn't get it yet? You should have one, right? Yeah. You can get one. I think you have one. Who else haven't got it yet? You got it?
One very simple question.
Yeah.
What is the Glassdoor review rating for Silicon Valley?
Yeah. think we are done.
One more thing.
Yeah, just give it to lottery, whoever is left now. I don't want to. Huh?
Question with the answer closest to the.
Okay, okay, answers the closest. Okay, I'll repeat. Data center sales in 2021. Data center 13 million. PC sales. Closest number. So keep on saying. Okay. 340. Anybody else? Huh? What was it? Okay. Between that. Okay.
It says 340 million.
340. We already have a 340. Okay, 345. It is closest. 343 was the answer. You can take and pass it to your neighbor. And how many was your embedded devices? You have the 15 billion devices. 15 billion devices. Did you get it already? Not yet? Okay. You have it now. All right, we are done.
Thank you very much for the.
I hope you enjoyed this session, and if you have any questions, you can drop an email or connect with Dixon. And my email address is also there. So if you have any questions, you can reach out to me directly. So thank you very much for listening.
Thank you.